a video of a bowling ball moving across the lane at a constant velocity. The formulas that I use in this experiment are V final equals V initial plus F net divided by mass times delta T. Final position equals the initial position plus the edge velocity times delta T, and the velocity of the ball is equal to the change in distance divided by the change in time. So for the initial conditions of this lab, I looked online to find the mass of a bowling ball to be 5.443 kilograms. The diameter of the bowling ball was 0.216 meters, which I used to calculate the distance in tracker. And after all this, I found the velocity to be 5.2 meters per second in the x direction. Okay, I put the video into tracker, and the ball moved rather fast, so I had to isolate it between very small frames. And once again, I had found the diameter of the bowling ball to calculate the distance, as shown here in tracker. And the bowling ball traveled in the positive x direction, as indicated by my axis. And on the side is the graph of the velocity and the data points used. And as you can see, it produced a straight line, which confirms that the net force was 0 and it moved at a constant velocity. Okay, I also used VPython in my experiment to calculate the update position of the ball. As you can see, I found the mass of the ball online to be 5.443, and I set the origin vector at 0, 0, 0. And the velocity only took place in one direction, which was the positive x direction, and to the right along the graph. And as you can see, I used my initial conditions and the formulas that I showed earlier in the video. And since the ball is moving at a constant velocity, you know that F net is equal to 0, which is my F net vector is 0, 0, 0. What you are seeing now is the VPython program that I showed you earlier, and this is what happens when you run the program. As you can see, the ball moves to the right, just as it did in the video, and the graph looks similar as it did before. It moves in a straight line, a constant velocity. And because the shapes are similar, I can say that my data from tracker is accurate. Here's a comparison of the two graphs that you saw earlier. The blue dots represent the data from tracker, which was taken directly from the video. And the red is the experimental data used in VPython to calculate. As you can see, both lines are very similar, which means the results were accurate. And the ball moves at a constant velocity in the positive x direction. Okay, the what-if question asked during this lab was, what would happen to the data if I was to move my origin to a place other than 0, 0, 0? As you can see here, I moved my x position starting at -5. As you can see, there is no major shift in the graph. The only difference is that it starts at a different place and ends at a different place. However, the graph still follows the same shape, meaning it still moves at a constant velocity, and the net force is not affected in any way. Okay, what does it mean? Your observations can be predicted well by your computational model when you set the net force equal to 0 in your model. Is it possible for you to say how many pushes and pulls are added together to give 0 net force in the case that you observed? When the ball moved across the bowling alley, it moved across the floor, which provided a force of friction. However, the bowling lane was very slippery, which minimized the friction as much as possible, theoretically allowing a net force of 0 as the ball moved across the lane. Also, there's a force of gravity acting downward, but that was zeroed out as well by the normal force pushing in the upward direction. So overall, the net force of the ball was in fact 0.